Hello, everyone, and welcome aboard. Have you ever looked at a massive cargo ship and wondered how it is manages to stay upright amidst the waves? Today, we're diving into the fascinating world of ship stability, exploring the fundamental principles that govern a vessel's equilibrium. Well, we all uncover the secrets behind buoyancy, center of gravity, and other key concepts, making them easy to understand and clear illustrations and the real world examples. Let's get started. Number one is buoyancy. The upward force. Buoyancy is the upward force exerted by a fluid like water that opposes the weight of a submerged object. A ship floating in the water, the weight of a ship acts downward, while buoyant force acts upwards. Center of buoyancy. This is the point where the buoyant force acts on the ship. It's essentially the center of the volume of water displayed by the ship. This represents the vertical distance between the keel to the bottom of the ship and the center of buoyancy. This is a buoyancy. And picture ship floating in water. The ship weight pulls it downwards while the water pushes upwards, creating a buoyant force. The buoyant force must be equal to the weight of the ship for it to float. The location of the center of buoyancy depends on the shape of the ship and the amount of water it displaces. Center of gravity. The balancing point. Center of gravity. This is the point where the entire weight of the ship is considered to be concentrated. It's like the balancing point of the ship. This represents the vertical distance between the keel and the center of gravity. This is the center of gravity. Imagine a ship with its weight evenly distributed. The center of gravity would be located at the geometric center of the ship. The location of the center of the gravity significantly affects the stability of the ship. A lower center of gravity makes the ship more stable, while a higher center of gravity makes it less stable. So, number three, metacenter, the point of stability. Metacenter, this is a theoretical point that determines the initial stability of a ship. It is the point where a vertical line through the center of buoyancy intersects center center line of a ship when it's tilted. Imagine a ship tilting slightly. The center of buoyancy shifts to the side, creating rotating moment. So this is a metacenter. It intersects. The location of the metacenter relative to the center of gravity determines the ship's stability. If the metacenter is above the center of gravity, the ship is stable and will tend to right itself when it's tilted. If the metacenter is below the center of gravity, the ship is unstable and may capsize. Next is the metacentric height, the key to stability. This is the vertical distance between the center of gravity and the metacenter between the center of the metacentric height is the vertical distance between the center of gravity and the metacenter. This a larger metacentric height indicates greater initial stability. A smaller metacentric height indicates the less initial stability. The metacentric height can be adjusted by changing the weight distribution of the ship Lastly, the writing arms, the restoring force. These are the horizontal distances between the center of gravity and the vertical line connecting the center of buoyancy and the metacenter when the ship is tilted. Imagine a ship tilted a certain angle. The writing arm is the horizontal distance between the center of gravity and the vertical line connecting the center of buoyancy and the metacenter. The writing arm represents the restoring force that acts to return the ship to an upright position. That's all. Thank you.